Implementation of China's next-generation supersonic jet technology by 2025, for phases with a $1.8 billion budget and advanced aerodynamic innovations. Introduction. China has embarked on an ambitious journey to re-enter the commercial supersonic aviation market with the development of its next-generation supersonic jet, the C949. Planned for unveiling by 2025, the C949 aims to revolutionize air travel with advanced technology and improved environmental considerations. This initiative is part of a broader strategy supported by a budget of $1.8 billion structured into 4 distinct phases. Alongside the C949, China is also advancing other supersonic projects, notably the Quantianhou, showcasing its commitment to becoming a leader in the global aerospace sector. Phase structure and timeline. The development of the C949 is organized into 4 key phases. 1. Research and development 2023 to 2024. This initial phase focuses on the design and engineering aspects of the aircraft, involving extensive research into aerodynamic innovations and materials that can withstand supersonic speeds. Engineers at Mach, China's state-owned aircraft manufacturer, are working on creating blueprints that will ensure the aircraft meets the intended performance benchmarks while minimizing noise pollution. 2. Prototype construction 2024 to 2025. Following the completion of R&D, the construction of the C949 prototype is slated to commence. This phase will involve assembling the aircraft based on the finalized designs and testing various systems to ensure safety and efficiency. 3. Testing and certification 2025 to 2026. Once the prototype is built, it will undergo a series of rigorous test flights to evaluate its performance under different conditions. This phase is crucial for obtaining the necessary certifications from aviation authorities, which will allow the C949 to enter commercial service. 4. Market launch and production 2026 to 2028. After successful testing, the C949 will be officially launched into the market, with production ramping up to meet anticipated demand. The goal is to have the aircraft operational and available for commercial flights by 2028. Technical specifications of the C949. The C949 is designed to fly at speeds of Mach 1.6, significantly surpassing the capabilities of its predecessor, the Concorde. With a range of up to 11,000 kilometers, approximately 6,800 miles, it can cover distances that allow for non-stop flights from London to various destinations in Asia, an improvement over the Concorde's maximum range of around 4,500 miles. One of the most notable features of the C949 is its focus on noise reduction. The aircraft aims to produce sonic booms at only 89.3 decibels compared to the 105 decibels generated by the Concorde. This reduction in noise pollution is achieved through a reverse camber fuselage design, which mitigates the shock waves generated when flying at supersonic speeds. The C949 will have the capacity to carry 168 passengers, exceeding the Concorde's maximum capacity of 128. Although it will not reach the same top speed as the Concorde, which flew at Mach 2.2, the combination of speed, range, and passenger capacity positions the C949 as a competitive entry in the supersonic market. Emergence of the Quantianhou. While the C949 represents a significant step for commercial aviation, China is also advancing the development of the Quantianhou, a supersonic aircraft capable of reaching speeds up to Mach 4. Developed by Sichuan Lingkong Tianqing Technology Company, the Quantianhou is intended to operate in near space between 20 and 100 kilometers above the Earth and is expected to make its first flight in 2030. The Quantianhou aims to test high heat-resistant materials and advanced aerodynamic designs that could redefine the standards for supersonic travel. With its ambitious speed targets and operational scope, the Quantianhou is positioned to advance China's leadership in aerospace innovation. Strategic implications and global competition. China's renewed focus on supersonic jet technology reflects its strategic intent to compete in the global aerospace sector, particularly against established players in the United States and Europe. The emergence of multiple projects including both the C949 and the Quantianhou highlights a significant national investment in aerospace innovation that could have dual-use applications including potential military advantages. The international aerospace community has taken note of China's entry into the supersonic race, with various companies in the US also pursuing similar projects. Domestic competitors such as Boom Supersonic and Spike Aerospace are developing their own supersonic aircraft, indicating a resurgence of interest in commercial supersonic travel following the retirement of the Concorde in 2003. Conclusion: China's ambitious project to develop next-generation supersonic jet technology, exemplified by the C949 and the Quantianhou, showcases its commitment to advancing its position in the global aerospace market. With a structured four-phase approach and a substantial budget, China aims to not only revive commercial supersonic travel but also enhance its technological capabilities. As these projects progress, they will likely shape the future of air travel and redefine the competitive landscape of the aerospace industry. The coming years will be crucial in determining how effectively China can translate its ambitious plans into operational aircraft that meet the demands of the modern aviation market. The content provided discusses the ambitious plans of China to develop next-generation supersonic jet technology, particularly focusing on two main aircraft, the C949 and the Quantianhou. Here are some counterintuitive points extracted from the information. 1. Speed versus noise reduction. While the Concorde was known for its impressive speeds and was celebrated for its ability to cut travel time, it was also notorious for its loud sonic booms, which limited its operational routes. The C949 aims to fly at a lower speed of Mach 1.6 compared to Concorde's Mach 2.2, yet will produce significantly less noise, with sonic booms measured at 89.3 decibels compared to Concorde's 105 decibels. This suggests that advancements in technology allow for quieter flights at lower speeds, which might be more commercially viable despite the lower top speed. 2. Investment in commercial versus military applications. The budget of $1.8 billion and the development of supersonic jets might initially appear to be aimed solely at commercial aviation. However, there is a dual-use aspect to this technology that raises concerns about potential military applications. The projects are framed as a means to re-enter the commercial supersonic market but also hint at China's broader military ambitions, countering the idea that such aerospace innovations are purely for passenger travel. 3. Multiple projects amidst competition. The presence of multiple Chinese initiatives like the C949 and the Quantianhou may suggest a competitive advantage in the aerospace sector. However, the timeline for the Quantianhou's first flight in 2030 and its goal to achieve Mach 4, twice the speed of Concorde, seems overly ambitious when compared to the steady, methodical approach typically seen in aerospace development. This could be interpreted as a sign of overreach rather than a true competitive edge. For historical context and market dynamics, the initial failure of the Concorde and the cessation of commercial supersonic flights in 2003 due to safety and noise issues presents a stark backdrop for China's current ambitions. It is counterintuitive that decades later, there is a renewed interest in supersonic travel given the historical challenges. This could imply either a significant leap in technology that mitigates past issues or a disregard for the lessons learned from earlier attempts. 5. Global competition. While China is entering the supersonic race, it faces competition from established aerospace players in the US and Europe. The assertion that China's advancements could catch up quickly with or surpass these established entities belies the complexities of aerospace development that often require decades of refinement, regulatory approval, and public acceptance. 6. Passenger capacity and market viability. The C949 is designed to accommodate more passengers than the Concorde 168 versus 128, suggesting a potential increase in market viability. However, a larger passenger capacity does not necessarily guarantee commercial success, especially if operational costs remain high or if regulatory challenges arise. This reflects an optimistic outlook that may not align with market realities. 7. Technological leap versus incremental development. the narrative suggests a technological leap with the Quantianhou set to operate in near space and test advanced materials and aerodynamics. This could be seen as an excessively ambitious goal, especially given that such technology has not been fully proven in commercial applications. The expectation that these advancements will lead to immediate practical applications may overlook the gradual nature of technological integration into commercial aviation. In conclusion, the ambitious plans for China's supersonic jets bring to light several counterintuitive aspects regarding speed versus noise reduction, military versus commercial applications, the dynamics of global competition, and historical context. These points challenge the perception of straightforward advancements in technology and highlight the complexities and potential pitfalls of re-entering the supersonic aviation market. In the report regarding China's next-generation supersonic jet technology, several critical elements may be overlooked by readers which hold significant implications for both the aerospace industry and geopolitical dynamics. Below are the most important points that deserve further attention. 1. Technological innovations and noise reduction. The C949 jet is designed with a reverse camber fuselage, a significant aerodynamic innovation aimed at reducing sonic booms to 89.3 decibels. This is noteworthy because it shows a commitment to addressing one of the primary criticisms that led to the Concorde's decline: noise pollution. The implications of this design are multifaceted. Regulatory approval. By significantly lowering noise levels, the C949 may gain regulatory approval for overland flights, which were prohibited for the Concorde due to noise complaints. This would open new routes and markets that were previously inaccessible for supersonic travel. Public acceptance. The quieter operation could lead to greater public acceptance of supersonic travel, which has been a barrier to widespread adoption. 2. Dual-use technology concerns. The potential dual-use nature of the technology is significant. As noted, the development of supersonic jets like C949 and the Mach 4 Quantianhou could have military applications. The technology behind these jets may translate into advanced military capabilities such as rapid deployment. Supersonic jets can be used for quick troop transport or reconnaissance missions, thereby enhancing military readiness and strategic mobility. Geopolitical tensions. The advancement of China's aerospace capabilities could escalate tensions with other nations, particularly the United States, which may view these developments as a threat. This could lead to increased military spending or technological countermeasures by other countries. 3. Investment and economic implications. The $1.8 billion budget allocated for this supersonic initiative reflects China's strategic investment in high-tech sectors. This level of investment has broader economic implications. Job creation and technological leadership. The initiative is likely to create thousands of jobs in engineering, manufacturing, and research, positioning China as a leader in aerospace technology. This could shift the global balance of technological power in aviation. Market competition. With several companies including Boom Supersonic and other startups also pursuing supersonic travel, competition is likely to drive innovation and reduce costs, potentially revitalizing the commercial aviation market globally. 4. Timeline and milestones. The ambitious timeline outlined in the report indicates a rapid acceleration of China's aerospace capabilities. Short development cycles. The planned test flights of the Quantianhou by 2026 and its operational debut by 2030 signify a fast-paced development cycle, especially compared to traditional aerospace projects that often take decades to materialize. This could indicate a shift in how quickly aerospace projects can be developed and brought to market. Strategic planning. The phased approach of the C949 project allows for continuous assessment and integration of new technologies, positioning China to adapt quickly to any advancements in supersonic technology or changes in market demand. 5. Global aerospace competition. China's re-entry into the supersonic aviation market is not just about developing a new aircraft, it represents a strategic move to compete directly with established aerospace powers, particularly the US and Europe. The significance of this competition includes innovation race. The launch of the C949 in Quantianhou could spark a new wave of innovation in the aerospace sector, prompting existing players to accelerate their own research and development efforts to maintain market share. Collaborative and competitive dynamics. As countries invest in supersonic technology, there may be a mix of competition and collaboration in research and development, potentially leading to new international partnerships or conflicts. Conclusion. The development of China's next-generation supersonic jet technology encompasses more than just the creation of new aircraft. It involves significant technological, economic, and geopolitical dimensions that could reshape the global aerospace industry. The emphasis on noise reduction, dual-use capabilities, substantial investment, rapid development timelines, and competitive dynamics are all critical factors that should not be overlooked. These elements suggest a profound shift in the landscape of aviation, with implications that extend beyond commercial travel into the realms of military capability and international relations. Recognizing and understanding these aspects is essential for comprehending the full impact of China's aerospace ambitions. 1. Technological advances in supersonic travel. The development of China's C949 and Quantianhou jets signifies a groundbreaking leap in supersonic aviation technology. The C949 aims for a maximum speed of Mach 1.6 and a range of 11,000 kilometers, utilizing advanced aerodynamic designs to minimize noise pollution. In contrast, the Quantianhou is projected to achieve Mach 4, focusing on near-space capabilities and testing high heat-resistant materials. These advancements not only enhance passenger experience but also position China as a formidable competitor in the global aerospace industry. 2. Strategic investment in phased implementation. China's ambitious $1.8 billion budget for the development of next-generation supersonic jets is structured into 4 distinct phases, emphasizing a systematic approach to aerospace innovation. This investment reflects a national commitment to reclaiming leadership in commercial supersonic travel, which has been largely dominated by Western companies since the Concorde was retired. Furthermore, the timeline of key milestones, including the C949's unveiling in 2025 and Quantianhou's first flight in 2030, illustrates an aggressive development strategy aimed at rapid technological deployment. 3. Dual-use technology and military implications. The advancements in supersonic jet technology raise concerns about dual-use capabilities, where developments intended for commercial aviation could also be adapted for military applications. The connections between Chinese aerospace firms and the People's Liberation Army heighten these concerns, indicating that the technology could serve both civilian and military interests. This potential dual-use nature of supersonic technology could lead to increased geopolitical tensions, particularly in the context of China's ambitions to enhance its military capabilities. 4. Global competition and the revitalization of supersonic travel. China's entry into the supersonic race introduces significant competition for existing Western companies such as Boom Supersonic and Spike Aerospace, which are also developing their own supersonic passenger aircraft. The renewed interest in commercial supersonic travel reflects a broader trend in the aerospace sector to improve speed and efficiency in air travel, with multiple players vying for market leadership. The emergence of China's C949 and Quantianhou highlights not just a technological challenge but also an economic one, as nations aim to capture lucrative markets in the aviation industry. 1. The Concorde Project 1960s-2003. The Concorde was a turbojet-powered supersonic passenger airliner that was a joint venture between British and French aerospace companies. First flown in 1969 and entering commercial service in 1976. The Concorde was capable of cruising at speeds of Mach 2.04, about 1,354 miles per hour. It significantly cut transatlantic flight times, making it possible to fly from London to New York in under 3 hours. However, the Concorde's operations faced challenges due to high operational costs, limited routes, and public concern over sonic booms, leading to its retirement in 2003 after 27 years of service. 2. NASA's X-43A 2001. the X-43A was an experimental unmanned aircraft developed by NASA as part of the HyperX program to demonstrate air-breathing scramjet technology at supersonic speeds. On November 16, 2004, the X-43A achieved speeds of Mach 9.6, about 7,310 miles per hour during its flight, setting the world record for the fastest air-breathing aircraft. The program was pivotal in advancing the understanding of hypersonic flight and has implications for future military and commercial aviation, paving the way for new types of aircraft that could operate at speeds previously thought unattainable. 3. Boeing's Sonic Cruiser 2001. Announced in the early 2000s, the Sonic Cruiser was a concept for a commercial aircraft capable of flying at speeds greater than Mach 0.98 with the goal of breaking the sound barrier without creating significant sonic booms. Boeing aimed to create a new generation of air travel that would significantly reduce flight times while maintaining efficiency. However, the project was ultimately shelved following the events of 9/11 and a shift in airline demand towards fuel-efficient subsonic aircraft, highlighting the challenges of developing commercial supersonic travel in a market focused on cost and efficiency. Future outlook: implementation of China's next-generation supersonic jet technology by 2025. China's aerospace ambitions are rapidly evolving, particularly in the realm of supersonic jet technology, characterized by the development of the C949 and the Quantianhou. As the country aims to re-enter the commercial supersonic aviation market by 2025, several predictions can be made regarding the future of this technology and its implications. Phase 1: Foundation and Research 2023 to 2025. By 2025, China is expected to complete the foundational research and development phase for the C949 with a budget allocation of $1.8 billion. This phase will focus on advanced aerodynamic innovations, noise reduction technologies, and the integration of sustainable materials. The C949 is projected to operate at Mach 1.6 and feature a range of 11,000 kilometers, positioning it as a viable alternative to the Concorde, which ceased operations in 2003. The emphasis on reducing sonic boom levels to 89.3 decibels will likely facilitate overland flight routes that were previously banned for supersonic aircraft, thereby expanding potential market opportunities. Phase 2: Prototype Development and Testing 2025 to 2026. In 2026, the first test flights of the C949 prototype are anticipated. This phase will include rigorous flight tests to validate the aircraft's performance under various conditions, focusing on speed efficiency and noise metrics. Additionally, the introduction of the Quantianhou prototype capable of reaching Mach 4 will signify China's ambition to push the boundaries of supersonic travel. The successful completion of these tests will solidify China's position in the global aerospace market, potentially attracting international partnerships and investments. Phase 3: Commercial Launch and Market Penetration 2027 to 2030. Assuming successful test flights, the commercial launch of the C949 could occur by 2027. With its significant range and reduced noise pollution, the aircraft could capture a share of the high-end travel market, appealing to business travelers and luxury tourism. The emergence of multiple supersonic projects, including those by Western competitors such as Boom Supersonic and Spike Aerospace, suggests a competitive landscape. However, China's advancements in technology may allow it to establish a first-mover advantage, especially in regions where demand for faster travel is high. Phase 4: Expanding Technological Applications in Military Potential 2030 and beyond. By 2030, with the anticipated first flight of the Quantianhou, China will likely explore dual-use applications of its supersonic technologies, which could extend to military capabilities. The development of high-speed drones and potential military aircraft may enhance China's strategic positioning and defense capabilities. This dual-use potential will raise international concerns regarding military applications, particularly as geopolitical tensions persist. Global context and competitive landscape. As China progresses in its supersonic endeavors, it will likely spark a renewed interest in supersonic travel globally. The competitive landscape will intensify with Western companies racing to innovate and improve their designs. Collaborations between aerospace manufacturers and governmental agencies such as NASA's partnership with Lockheed Martin will focus on minimizing environmental impacts while maximizing speed. The emergence of new technologies including hybrid electric propulsion systems and advanced materials will further redefine the parameters of supersonic flight. Economic and environmental considerations. The economic viability of supersonic travel will be contingent upon market acceptance and regulatory frameworks. As airlines and manufacturers address environmental concerns, the push for sustainable aviation solutions will shape future developments. Innovations such as sustainable aviation fuels and noise reduction technologies will be critical in gaining regulatory approvals and public support. Summary of predictions. 1. Short-term 2023 to 2025. Completion of foundational research and initial designs of the C949 with a focus on noise reduction and aerodynamic innovations. 2. Midterm 2025 to 2026. Successful prototype testing of the C949 and the Quantianhou validating their performance metrics and paving the way for commercial viability. 3. Long-term 2027 to 2030. Commercial launch of the C949 capturing market share in high-speed travel, while the Quantianhou sets the stage for advancements in near-space travel. 4. Beyond 2030, exploration of dual-use applications for military purposes alongside efforts to address economic and environmental challenges associated with supersonic aviation. China's commitment to advancing supersonic jet technology by 2025 is a pivotal moment in the evolution of global aviation. The outcomes of these initiatives will have lasting implications for the aerospace industry, shaping the future of air travel and international competition in the coming decades.